So we have been looking at these stations and how they are connected. Right? So first we checked whether you can go from one station to another station directly.
There's a train which goes from
There's one train which connects directly. Then we said whether you can change at one station and go.
Yeah.
Then we also tried to see if there is a way of going by more than one train by drawing that graph connecting the thing. But so far I think we haven't really looked at these other quantities which are there on these cards, like the time, how long it takes, or some of the each of these trains has a distance measure. So it might be interesting to keep track of that. What is the time it will take? For instance, if I can go from Pune to Secunderabad or Pune to Calcutta, then what would be the...
There are many trains. So.
Yeah, what would be the best way to go in terms of time or distance or both? Right?
You have to do both. I think sometimes distance is relevant, sometimes time is
relevant. It depends on, and also it depends on how many times you are connecting. It might be a short distance, but you might
the thing is that this processing, that is finding out the distance between Pune and New Delhi or whatever it is, we need only do it once. I mean, if you've done it once, then doing it again and again and again,
correct,
meaningless to do, right?
Yeah, so we should kind of
try and store it somehow.
Do it and record it.
Record it.
Yeah.
So what's a good way to record it?
So
use a graph like what we did earlier.
If we use a graph, in principle we could do that, but then for every connection that we have on the edge we have these labels, right? So earlier we had written some, so we have to put all this extra information, label it. Also, might be a little messy to...
Graph makes sense only probably if you put a few edges, right? If every pair is connected to everything else.
Yeah, then it will be very messy, I mean, to look it up. I mean,
too many edges, right? Just a few edges for the graph.
Yeah.
So in this case, we want to take, let's say, these 5 stations and work with these 5 stations, find all the trains.
Correct. So we want to say, for example, what is the Pune to Calcutta? What is it from Pune to Nagpur? So we have how many? 5 times 4, 20, and of course...
we're not looking Pune to Pune, right?
Yeah, Pune to Pune.
But anyway, we can make a table of 5 by 5.
5 by
table.
5. Yeah, we can make a table. That's a good idea. Table. So we can have an entry for each starting point and each ending point, and then in this table at that position we
it's like a graph. Only thing is that all edges are represented.
Yes.
Right, in the table.
Yeah. So we could write down these stations. So should we write down these stations in some? So let's write it down in say alphabetical order. So we have Kolkata.
Okay.
Then Nagpur.
New Delhi.
New Delhi.
Pune.
Pune.
And then Secunderabad.
And Secunderabad. So this is one side of the table. These are the rows.
We can say starting from.
Yeah.
Is it? Rows.
Correct. Starting from, and on the top we will have the same thing, and I will just write one letter so that we don't have to write everything. So Nagpur, New Delhi, Pune, and Secunderabad.
So this is going to.
Starting from. So this is from.
And from and to. From and to. Right? From and to. So I want to go from Kolkata to Kolkata, does make sense?
Yeah.
I want to go from Kolkata. So if you draw the matrix.
Yeah, so let me just draw this
table, right?
So we have a table, right? So we have these kind of rows, and we have one column for each place we want to go to from each of the places on the rows.
Yeah.
So we end up with this
5 by 5.
5 by 5 table
with the diagonal, that is this one.
Yeah. So this is,
you just put across something.
So you can just block it off.
This so use meaningless, right?
Yeah, because we are not going to go from one station back to itself.
Unless you like stations. Just go along with the station count.
Yeah.
Okay, no, we are not.
Yeah, so here for instance, this is Calcutta to Nagpur, and this is Nagpur to Calcutta. Now they may be the same, but it may not be the same because of the other direction, and there are various other things like timing and all might be different.
Timing is different, definitely different. Distance also may be different. We don't know. We'll see.
Okay.
So what do you want to write in this cell? What do you want to write in this box?
So I think we would certainly want to write down. So what is our goal? Let us suppose we want to look at distance.
Yeah.
Right now we would like to write down the distance it takes, but there may be more than one train.
So let's write down the train and distance. Okay.
Yeah. So we write the train number and the distance on that train. Then we can choose the one which is best for whatever.
We can choose the least one.
Normally the least one.
Okay. All right, so we have to do 20, 5 into 4, 20 wells. All right.
Okay.
So, do we start? Kolkata to
Nagpur.
Nagpur. So, how do I do that?
So
Start
we,
with Kolkata or start with Nagpur? Kolkata, presumably.
yeah.
And look at trains starting at Kolkata or
Yeah.
passing through Kolkata. Whatever.
So we are now looking only for trains which directly
Depart from.
No, but also only direct connections. What
We are right now looking only for direct connections.
So basically we need to look at the trains here and then the trains which are also there in Nagpur.
Overlapping. Right?
Right.
So, we have to see Kolkata, Nagpur, compare the two
Yeah.
and see if there are any overlaps. So, 022.
So maybe I can, you
02?
can call out the numbers and I can check
You
the
can
Nagpur
check,
list.
yeah,
Yeah.
okay.
Yeah.
So, 2202,
Nope.
2214,
Nope.
142, 2222,
1222. Yeah, that's there.
142.
So one.
1222. Okay.
Yeah. So that's there.
So, that departs Kolkata at 8:20.
Okay. So we can write. So let me put. So one.
So, what do we need to look in that train? What are we looking in the train? We are looking at the distance.
Distance. Yeah. So we
So
have
starting from Kolkata, it's going further than Nagpur, right?
Yeah. So
we have to
Nagpur
only
is
look up
1131.
1131.
So the train number. So we should maybe write it in two different colors. So the train number is
142s.
and the distance is 1131.
Okay.
Okay. So this is one train. Yeah.
And then this is 12262.
Yes, that's also there.
Oh, all right. 12262. Right. There are multiple trains.
But it's apparently following the same route because that also has the same distance. So
No need to write, huh? Oh, just write. Okay, let it write.
12262 and it's also 1131.
Same track, huh?
Same track. I
Huh?
think. Yeah.
Are the stations the same also?
We can look. 1, 2.
Maybe. Should be, no?
Yeah,
Otherwise,
I
carrying the
think
distance without the same stations is.
Yeah. Kolkata, Tata Nagar, Bilaspur, Nagpur, and this one is going to Mumbai and this one is going at Bhusawal they split. Bhusawal, Igatpuri. This is Bhusawal, Manmad. So they go the same up to Bhusawal and then they take different directions.
Bhusawal is an interesting station. Okay, anyway. So, so we've done that. 12273.
No.
7, okay, 74 is not, it's arriving. 02245.
No.
Then 12259.
12259. No.
Okay.
So there are only
there are
two
more.
trains.
There's some more.
Okay, there's some.
02201.
No.
02201 and 02213.
No.
Okay. So we have taken all the trains departing from Kolkata,
Check those which pass through Nagpur.
pass through Nagpur,
There are two of them.
and
we have noted down the distance on both of them.
both of them they're the same.
Happens to be the same.
So in this case, the distance from Kolkata to Nagpur is
1131
113
by direct train.
by direct train.
And we now know this, so later on if we need to refer to this, we just have to look up this row for Calcutta and the column for Nagpur and we're done.
Done. We don't need to look at the cards.
Yes.
So this is a way of processing the information, storing it. Huh?
Yes.
All right. Okay.
So let's
Now,
do one more.
Let's do Secunderabad, Nagpur. We did Kolkata to Nagpur. What is ND? New Delhi.
New Delhi.
Oh, that's going to be a lot of trains, huh?
Yeah. So let's do maybe Nagpur to Secunderabad.
Nagpur to Secunderabad. There will be no trains maybe. Let's see.
Let's see.
Let's see. Okay. Departure Nagpur 12261,
No.
12221,
No.
02286.
Yes, 02286 is there.
Okay.
So let's see what is 02286. Nagpur to Secunderabad. So now we have to do some subtraction because it is not starting from Nagpur.
All right.
So the train number is 02286 and the difference is, so 1660 is the distance from Delhi, 1083 is the distance from Delhi, so we have to subtract 1083 from 1666, so we get 577 I think. That makes sense?
Minus 37, 5 minus 8, 7. Yeah.
So this is 577.
577.
That's the distance from Nagpur.
Okay. Then where have we come to? 02286.
Yeah.
Then 12270.
No.
Then 12290.
Nope.
12269.
Nope.
02285.
That's the pairing train, but it's going in the other direction.
Okay, no, we don't want that.
Yeah.
12222. We saw this train. Okay.
No.
12262.
No. So there's only this one train. So
One
we have
train,
a unique.
So 577. You got it. All right. Okay. Let's do something.
Yeah. Let's do something with Pune. So Pune to Delhi, or too many trains. Let's see. Let's try with the Pune trains. Yeah.
Pune with Delhi.
Yeah.
Okay.
Yeah.
12219.
Let's
check both the cards. Yeah.
No.
122. Okay. These are all arriving. 12220.
12220. I don't see.
12263.
Nope.
Is there?
Yeah. Ah, there it is. Shows you.
12263 is
okay. 12263 is actually it's good. No subtraction required because it is running from Pune to Delhi.
All right.
Via Mumbai. So we now put this in the Pune to Delhi box. Pune to Delhi box 12263, and it says it is 1520. So 1520. Okay.
Then there is 12221.
12221. I don't see. No.
Then there is 12298.
Nope.
Okay, so there's only one train.
One train, and
it is a distance of 1520.
1520.
Okay. Now see, what have we not considered so far? Which pairs have we not looked at so far?
So we have done Calcutta to Nagpur, we have done Secunderabad to Nagpur, and we have done Delhi Pune. So all stations have been checked even once, at least once, but we
Delhi
can
Kolkata we didn't do.
Yeah, Delhi Calcutta might be very interesting, although there may be many trains. But let's try it. Yeah.
Okay.
So Calcutta has fewer, so let's try the Calcutta.
Okay, I'll start with Calcutta. Departure. 1 4 2s.
One with 4 2s, I think doesn't go this side at all. We have seen that before.
Yeah, we have seen it before. 12262.
63 is there. No, not 62.
Really? Okay. 12273.
73 is there. It's actually Kolkata to Delhi. So 12273, and it's 1529.
Okay. The next one is arrival, so I am leaving it. 02245.
02245. Nope.
Okay. These two are arrivals. Then 12259.
12259 I think should be there. Yes. 12259.
It's passing through Delhi. It's not stopping at Delhi. Interesting.
Yeah, it's actually going to Bikaner.
Oh.
So, and it's doing something. 12259 is actually a different. So we should find out why. It is 14. It's a shorter route. 1453, right?
It's via Kanpur. Can you check that one?
Yeah. So this was via Kanpur, and the other one is via. So Kolkata. So this is very different route. So Kolkata Dhanbad, Kolkata Asansol, Jasid, Patna, Varanasi, Kanpur, and this is doing an extra detour via this. See Varanasi, Kanpur, and this is going via Patna, Varanasi, Kanpur. So I think this extra stretch here. So Varanasi, if you look, this is 667, and here it's 744. So it's already accumulating some.
Because it's going through Patna, it has added some more distance.
Yeah,
that
so
one is not going through.
Yeah, that's not going to Patna, and that should be roughly. So at this point, about 67, 744. Yeah, about 70 kilometers difference, and that's around 70 kilometers difference here. So that's where it's.
Okay.
Okay. So we have found at least some interesting thing here between Calcutta and Delhi. There are at least two trains. 61.
022. This is all arrival. 02201.
No.
02213.
No.
Okay, so there are only 2 trains.
2 trains, but they are different routes.
They are different routes.
Yeah. So they actually.
Routes.
So here we actually have.
Finally found something where you have two trains with 2 different distances.
Correct. Yeah. So here we would possibly record that this is a better one. Right? So this is useful to know. So in this way we could populate this whole thing in terms of distances. And then we would know for every pair by a direct route what is the best way to go. And of course, if we do it for all
in this case, all the trains, every station and every station here is connected.
Is connected by a direct train.
Direct train. Therefore, this table
will have every entry will have.
Suppose a train, there was a station, another station which was not connected.
Then you will basically have a blank space.
Blank spot. So, in a sense, it's like a graph, right? Only thing is, in this case, this is what we call a clique, right? Everything is connected to everything else.
Yes.
But if something were not connected, there will not be an edge.
Correct.
And on the edge, what do we have? We have the label. Label is now in this case
a train number and a distance, but it's a list of these train number, distance pairs.
You could have more than one edge also, right?
Yes. You could have more than one edge.
One train, one edge.
You could do that. You could, for every train, you could draw one edge which just has.
Normally, a graph has only one edge between 2 nodes. Huh?
Yeah. Normally, yeah. It is just a question of becoming messy. Because
you would like write 2 edges, 2 edges.
You could write 2 edges, but
like
I think
said there we put, you remember we did this maths, physics and all that. It's possible that one student can mentor another student in maths and physics, so there could be 2 edges, right?
Correct. 2 different labeled edges.
2 labeled edges.
Yeah.
Because you could have one edge and label it maths, physics, or you can put 2 edges, one with maths, one with physics.
Right.
But so assume for a moment that these are 2 edges, just so that it's easier to understand.
Yeah.
So edge is a train in that case.
Yeah, and on that train we are now putting the train number and the distance.
Distance you are putting.
And we could also have put the time in the same way. We could have calculated based on.
You want to do some of these? We can at least try doing the time.
Okay, the ones that we know, for instance, we could do that. So let's see, for instance, this. Shall we look at these 2 trains, the ones that we have already found?
Kolkata and Delhi.
Yeah. So we know the trains. So 12:59. So this is one of them, right? So this starts at Calcutta at 18:31 on day 1 and reaches New Delhi at 11:45 on day 2.
Departure, arrival is 6:25.
Sorry, 11:31 on day 2. So basically it starts at 6:31 p.m. and reaches the next morning at 11:31 a.m. So here it is 11:31 and this is from 6:31, so 29 minutes, 29 minutes it will be 7 o'clock. So another 5. So 5 hours 29 minutes there and 11 hours 31 minutes here, right? So 16 plus 17 hours it's taking.
17 hours.
Exactly 17 hours, right? So we can write, so I will kind of spill it over. So this is 59. So this is, right now, let's assume that the.
So if you put that also, that information is also put.
Yeah.
But is it every day?
No, this is Monday, Wednesday, Thursday, Sunday.
So that gives another complication, no?
So you can go in 17 hours
provided you
start on those 4 days. Let's look at the other train, 73, and just see whether it goes more frequently and what is the time it takes. Since it takes longer distance, it presumably takes longer time also, but we cannot be sure about that. Okay, so let's see. This now leaves at, first of all, it's only on Monday, Friday. So on Monday both are there, so you can compare. Others, Friday and Wednesday, Thursday, Sunday are 2 different days. 8:35 and it reaches at 6:25. So it's almost 24 hours, right? So it is like 6:35 would be 22 hours. Because it's day 1, 8:35, it's 21 hours and 50 minutes. So
21 hours and 50 minutes.
Yeah, and notice that actually the distance is not that much more, right? On the distance scale.
But you may be going to Patna and stopping. See, you can see Venkatesh.
Because it is not even 10%. Because if it was 1453, another 145 kilometers would be 1,600. So it is less than 10% of extra distance, but it is taking a good amount of extra time, right? Almost 1/3 as much time.
It's a very slow train. So not only is this a faster train, it's also a
shorter in distance and much faster.
The only problem is that if you leave on Friday,
yes, then it will be much better.
You have to wait till
Sunday.
So you not even Saturday.
So you will have 2 full days and then you would have the pleasure of taking a shorter train, whereas you would essentially
so if you miss, for some reason, if you miss this train, which is at 6:30 on Thursday,
then
let's say you landed in the station at 7 o'clock.
Then you might as well take this train.
Might as well take this train. 8:35 next morning.
Friday morning, rather than wait till Sunday.
Wait
so
till
that's
Sunday.
an extra factor which we have not yet recorded there.
Yeah.
So it's a bit misleading without that information, right? So we could then take this edge and we can write all this information that we know about the train on that edge. So one thing is that we have only said the time, but we have not said when it reaches. So that might also be relevant if we are looking at, say, connections and so on.
Correct. Oh, maybe we should look at connections. You know, I mean, all right. So this is interesting. I mean, what we have said basically is that you can digest all these complex information into a simple table.
Yeah.
We like tables. We have been using tables.
Yeah. So right? Earlier we did a graph, and then we said the graph will become messy. But so this is like a graph, as we said. Each of these entries is like an edge. It's just that instead of writing it in this picture form and having to squeeze in all the information in the small space that we have kind of allowed ourselves. So here we lose some information about pictorially looking at it, but we gain this organization.
I was thinking this matrix, if you really had it between all stations and all stations, you could do something more interesting, right? You could use the matrix to figure out how to go via one station or another station.
Yeah, for sure. Because
can you do that?
Yeah, so let's give an example. Maybe we can find an example. So supposing we know. So last time we had calculated that, for example, if you wanted to go, so we said that if you wanted to go from Pune to, so we had calculated this graph, right? And we had said that Kanpur had this peculiar situation where none of these 5 stations were directly connected to Kanpur. So you would have to go from via Delhi or via Calcutta to go from here to there. Right? So now if we look at this table, there would be no entry, say, between Pune and Kanpur.
Yeah.
So that square or that cell in that table would be blank. So now you have to look for some station which is connected to Pune and which is connected to Kanpur. So you have to find such an entry. So
you can look in the matrix between Pune and some station X, where there is an entry. And
from that
entry, from that X, there has to be an entry to
Kanpur.
Yeah. And therefore I can find out. So if there is a X such that Pune to X and X to the entries, then I can go.
So systematically
I can do that with 2 stations also. I can do Pune to X, X to Y.
So basically, so if you had this Pune thing, then it would have.
You know, the graph it makes actually, this is a better thing to do with graph, because it basically means that I can go from Pune to something with an edge, and from that you can go with an edge.
Yeah. So if you look at the row for Pune, for instance, right? So there would be some entries which are there, and some entries which are not there. I mean, when I write an X, it will blank. So in particular, we know that the column for Kanpur is blank because we have no train going from Pune to Kanpur.
But Pune to Delhi is there.
Yeah. So for instance, here we might have found a little further down, you might have found New Delhi.
In fact, actually we searched the other day, right? The only way is to go via Delhi.
Go via Delhi.
Okay.
So what we would have to do is now, if you do it systematically for each of these.
So you will see that there is a Pune to Delhi, and then there will be another line.
So there will be a line for Delhi, right? And in this row, you will have to check that the corresponding column for Kanpur is marked with a tick.
So we are saying that there is a path from Pune to Delhi, there is an edge from Pune to Delhi.
And then there is a edge from that.
From Delhi to Kanpur.
Yeah.
But now we have more information in our graph.
Yeah.
We know the distance.
Yeah. So now you know that this is some D1 and this is some D2.
So right? I can find the distance by adding.
So therefore I will get D1 plus D2. Yeah.
I can.
You can do that. Because you will take that much, you will travel that much distance to get from Pune to Delhi, then
and
you will
get
get
2 trains over here, then I can take
the shorter of that,
shorter of those 2,
and the shorter of these, and get the shortest distance from Pune to Delhi.
But you know what? There is a possibility that not just Delhi, there will be something else also.
Yeah.
Right now, in this case, Pune to Delhi, only one way. Are there places here where you have 2 ways?
Well, not directly, but for instance, you can say Secunderabad,
You can go to Pune.
You can go to Secunderabad and you can go via Delhi to Kanpur, but you can also go to Vijayawada and then go via Calcutta to Nagpur. Right?
Oh, so no, but I'm just saying, say for example, Secunderabad I can go to Pune.
Yes.
Or I can go to Nagpur and then Nagpur to Pune.
Yes. And then you can ask whether they are the same distance or different distances.
And find out? I think this will be shorter anyway, I think.
Yeah, so I think Secunderabad Pune, because this is a direct train, I'm pretty sure that to go via Nagpur it will be longer. Yeah?
You try?
Yeah, you can try that.
So here again what we are doing basically is that if you don't have a direct route, in this case there is a direct route, so nothing much to do. But if there is no direct route, there may be multiple alternate ways of going from one place to another.
Yes.
So we have to take all the alternate ways, find the distance of all the alternate ways. How do you find the distance? Add. Add this distance, add that distance, right?
Yes.
This and this. So like that we will find all the ways, add all the ways, and choose the one which has the shortest distance.
Yes.
If you are looking at distance. Distance also means fare, no?
Yeah, usually the train fare is based on the distance that you travel.
So if you have only limited amount of money, it's a very useful thing, right?
Yeah.
You don't care about how much time you spend in the station.
Correct.
Right? It will take long time.
Right.
But shortest distance. So in that case, basically, shortest amount of money. In that case, basically, you just, so in this case, we can just try it. I mean, let's just try this. What are we trying to do?
We want to try from Secunderabad.
You have the train number. So we can just.
Yeah. So we have Secunderabad to Pune directly is 12220. Right. So that is Secunderabad to Pune directly.
It's 597.
Yeah. So let's write, maybe should we write it on this graph itself?
Yeah, you can put in bracket or something. 597.
597. Right. And now if you want to go Secunderabad to Nagpur, sorry, that is 85. So Secunderabad to Nagpur, that's already 578. So you're already in bad shape because most of your distance is already used up in this. Okay. And then you want to go from Nagpur to Pune by this 1222. Right.
Here's Nagpur.
So this is almost 900 kilometers. So it is 900 minus 11, 889 kilometers, right?
Yeah, 889, correct.
So this is a huge detour, because now if you go via Nagpur, then
so
you have to add 578 plus 889,
which is 1,300, 1,000.
Yeah, 300 and
467.
Yeah.
Is that correct?
Yeah. So you're doing
1467 versus 597.
Yeah. So there's absolutely no.
But sometimes it may turn out like that. You may have to go like that. Right?
Yeah. You may have
find
to
a shorter.
Correct.
So you can. So basically, this matrix. I mean, this graph and matrix are the same. We have written it using a.
Yes.
There's a name for that table. I mean, this table. If you're writing using a table for this graph.
Yeah. So usually we are looking now at these stations which are connected to each other. So if you look at the connected ones and you ignore the ones which are not connected, or rather it tells you which stations are connected, which are next to. So it's called adjacency. Adjacency matrix.
This one is called.
Yeah.
So the table is called an adjacency matrix.
Yeah, adjacency matrix. So adjacency matrix basically is the ticks and crosses. It tells you is it connected or not connected. And then you add this extra information which gives you some more information about the connection, like the train number, the length, the distance, the time it takes, and so on.
So we can use this matrix, adjacency matrix, like equivalent of the graph in a sense, right?
Yeah.
Whatever you want to do on the graph, we can do on the matrix.
Essentially.
And which is a table, so it's much easier to process in some sense in the computer, right, or whatever. Yes. So now the point is that two things we saw we can do. One is that find out whether there is a direct train. Just look in the adjacency matrix for a tick, right?
Yeah.
And now we also found out that you can find out whether there is a
one hop. Yeah. So basically for every tick, you go to the row for that tick and see if there is a tick to your destination.
Like that.
Right. So you check this guy.
One hop.
Go to that row, and if that row has a tick for Kanpur, you can go via this place to Kanpur. So next you go, and so you keep checking for each of these, And then if you have multiple such routes, then you can do this thing that we just said of comparing
the routes.
For each route, once we know that, we can do this
for each
minimum.
route you have to add.
Yeah, we
add
know
the distances.
for each route we can just look up the distances of the two legs and add it up.
Add it up.
And we can now take the minimum across all these different routes and to get the best possible.
Is there a possibility that you have three hops like this instead of 1 hop, 2 hops, 3 hops like that?
Yeah,
you
could
go
have
from
yeah, you could certainly have 3
Pune
hops.
to Delhi.
Yeah, so then you would again have to look for some tick in the.
So in this case, if you look at this graph, right?
Yeah.
We already saw, right? Bangalore, if you want to go to.
Yeah. So for instance.
Kanpur.
Yeah. Then you would have to go to Secunderabad and then go to Delhi and then come to Kanpur. Yeah. So this could be.
Or you could go to
Vijayawada, Kolkata and Kanpur.
Do you want to compare the distances?
Well,
we were doing it. Bangalore, Secunderabad, Delhi, Kanpur.
Yes.
Bangalore, Vijayawada, Kolkata, Kanpur.
Yes. So first let's look up Kanpur.
So that is like, in this table what we are doing then is, we're saying Bangalore.
Yeah.
Then you're checking that there is a tick mark to Secunderabad.
Yeah.
Then in the Secunderabad row you are going.
Checking a tick mark to Delhi.
Delhi.
And Delhi row will
Delhi
have
row tick mark to Kanpur.
Yeah.
And each of those entries you are picking up the train and the distance.
Yes.
And then adding it up.
Adding it up, correct.
Huh?
Yes.
And then again you will do the same thing. Bangalore, Vijayawada.
Vijayawada,
From Vijayawada, Kolkata.
And Kolkata, Kanpur.
Kolkata, Kanpur. Find the distances.
Yeah.
Add it up.
Yes.
Then compare these two additions.
Yes.
Let's do it. I think it's worth doing.
So let's take out Kanpur's data from here so that we can find out which trains pass through Kanpur. So this is Kanpur.
Train numbers are there. No?
Yeah. No, because we didn't write it down for the Delhi and Calcutta.
Oh, all right. Okay. Yeah, we can do that. Yeah.
So now let's go back and.
They weigh more than one, huh?
Yeah. So we can certainly do it. So now let's. I will just.
We only need to keep track of these specific things, right? We don't need all of them now.
Yeah. So we have. So what are the stations that we are interested in? Bangalore, Secunderabad,
Delhi, Kanpur.
New Delhi, Kanpur and Vijayawada.
Vijayawada, Kolkata.
So actually we are, okay, we want to go from Bangalore to Secunderabad, Bangalore to Vijayawada.
Yeah.
Then we want to go from Secunderabad to Delhi.
Yeah.
And we want to go from.
You can just put some tick mark, some indicator that you want that box.
Yeah. So we want this box.
You want that box.
We want this box.
You want that box.
Secunderabad to Delhi we want.
That box. Yeah.
Delhi to Kanpur we want. And then we also have a Calcutta there. So Delhi to Kanpur we want a box. Kanpur to anywhere we are not interested.
We are not interested, no.
Calcutta to Kanpur we want a box.
Yeah.
Okay, and then we want from Vijayawada to
Kolkata.
We want this box.
Okay, not that many. All right.
Right. So
good.
Once we have this, then we will.
Then we can do our problem, right? What we want to do.
Yeah.
Huh?
Yeah.
Okay, that's it.
So let's do Bangalore, Secunderabad. We already know there is only one train, right? So it's 1, 2, 2, 1, 3. So we can just look it up and sort it out. For that we are already calculated last time. So let's do the ones we already know. So 1, 2, 2, 1, 3. From Bangalore to Secunderabad is 688.
We should put this train back so that you don't get lost.
Okay, we'll put it back. Okay, so this is 1, 2, 2. Bangalore to Secunderabad is 1, 2, 2, 1, 3.
And distance?
And distance is 688.
Okay.
Okay. And now, what is the other one? Bangalore to Vijayawada is 02245. Let me put this train back in its place first. 65. 02245. So this is, no, it's not 02245, 02246. Sorry. Bangalore to Vijayawada is 728.
All right.
Okay, So this is the only thing that we know actually right now.
Okay.
Then Secunderabad to Delhi. So we did not do that before, I think. So we'll have to look at Secunderabad and see what all trains go to Delhi from there.
Yeah, we'll compare.
Yeah, so Secunderabad.
You can read out.
Yeah, so departure 12213.
Yeah.
Okay. Okay, so that is 688, 2374. So
2374 minus 688.
yeah, so that is 1686 maybe.
1686, yeah.
So that is one option. Secunderabad to New Delhi, right? 12213 1686. Okay. Then 122 no 02285. Is that a train for you? 02285. Yeah.
Yeah. Okay. We got two trains.
So let's see how this goes. Okay, so this is a straight train 16667, so slightly shorter. 1667.
Oh, very, very close, huh? 1686 and 1667. All right.
Yeah. Okay. Then 22204.
No.
No. And
12214.
12214.
12214. 13 is there. 14.
It's strange. Both these trains go in the same direction. It's very strange. So this should be going the opposite way. So I think there is some problem with this.
Okay, leave it. Drop it.
Yeah.
12220.
12220 is not there. Okay. So we have these two trains. So we have 1667 is our best way to go from Delhi to Secunderabad to Delhi.
Okay.
Then we have to do Vijayawada to Calcutta. So Vijayawada is with you, or I have to take out Vijayawada from this. Okay.
Okay, I have Kolkata. Let's compare.
22203.
222. No.
Then 222.
222 is not there.
Okay. 02245.
Yeah.
Okay. Okay, so 46 actually should. So 02246 Vijayawada to Calcutta is 1946 minus 728. So that's 1218. 1218, right?
Correct.
Okay. Then 12270, yeah?
No.
Or 12269.
No.
Okay, fine. Only one train. Okay, so that's done. Fine. So now we only
Two
have
more boxes.
to check Kanpur. So we have to do Kanpur. So let's look at Kanpur, Delhi first.
Kanpur, Delhi. Okay.
Yeah.
You start with Kanpur.
Yeah.
And go to Delhi, or
We want to go from Delhi to Kanpur. So let's look at arrivals at Kanpur.
Okay.
So 12260, does it come from Delhi?
12260.
That,
No. 12260.
12260.
I was looking at exits from Delhi. It's passing.
Yeah, seems to be
Must be
passing.
that Loharu, whatever the thing.
Bikaner.
Bikaner.
Okay, so here it's a direct thing from Delhi to Kanpur. It is 439, I think.
902 minus 463. So 439, correct.
Yeah.
439.
So 1260.
It's not that far, huh? Delhi Kanpur.
Yeah.
Okay. 439.
439. Okay. Then 73. 12273.
74.
Three.
73. Okay.
but it's arriving, so it's going the other way. So there must be a matching 74. 74 is 440. It's shorter. 12 to 74. No, it's not shorter. It's 1 kilometer longer. Sorry, 440. Okay.
All right.
Then
1 kilometer. Maybe that's a platform. Something, I don't know. Okay.
12 to 81.
12 to 81. Yeah.
Yes. That's also arriving in Delhi. So there must be a matching. 12 to 82 is probably the correct one. 12 to 82 is also 440.
12 to 82. Where is it? Ah, it's there. Yeah. Okay.
It's also wrong place. So these are both the same. 440. So it's some 439 or 440. Okay. Okay. So those are
Last
the trains.
one,
Those
Kolkata to Kanpur.
Yeah. So now Kolkata to Kanpur. So presumably one of these trains also goes to Calcutta. So
you want to look at Kolkata to Kanpur, right?
yeah. So the 60, 61. I think this 12 to 60, 61. I think seems to be
60, 61. Yeah. Yeah.
So we want to go from
60.
Kolkata to Kanpur. So 60 leaves. Oh, this is wrong. It doesn't go to Kolkata. So where is this one? Why does it say Kolkata to Kanpur? So there is some problem here. Right. So 12 to 60, 20 doesn't go through Kanpur at all. It does go through Kanpur. Here it is, sorry. So 61 is the correct one, or 59. 59 is Kolkata to Kanpur.
Okay.
And it is 1014 kilometers.
All right.
Okay. That's 59. 73 we saw.
73 is there, yeah.
Okay, so 73 is departing from Kolkata again. Okay, it was 1090. 12273 is longer. 1090. And 81, 82 you have? No. Okay. So now we have got everything.
Okay. Now we don't need the cards.
Yeah. Now we don't need the cards.
Okay.
So
we
now
only need the graph.
Yeah. And
We only need the table.
Yeah. So now we know that if we do
Okay.
Bangalore, Vijayawada, Kolkata, Kanpur. Right. So then we have
Vijayawada. Okay. Is that what we want to do? Bangalore, Vijayawada, Kolkata, Kanpur.
Yeah. So
okay.
then we have 728.
Plus.
Then Vijayawada is 1218.
Okay.
And then Kolkata, Kanpur, the shorter one is 1014.
Okay.
Right? And the other version is Bangalore, Secunderabad, New Delhi, Kanpur. So Secunderabad here will be 688, already shorter. Secunderabad to New Delhi was 1667, so this is a little longer. But New Delhi, Kanpur is only 439. Right? So if you look at this, it's almost it's about 3000. If you look at this, it is more like 2007. I mean, it's not a huge difference, but we could add it up. So this is 8, 16, 20, 4, 5, 6, 7, 9. Is that right? Or am I?
4, 8, 12, 8, 20, 2, 1, 3, 1, 4, and 2, 6. 2 and 2, 4, no? 0 plus 2 plus 7, 9, correct. Okay. And 1 plus 1, 2, correct. 2, 9,
Okay. 6, and now here we have 8 and 7, 15 and 9, 24. 5, 11 and 8, 19. 5, 11 and 6, 17. It's kind of close, huh?
2794. So it's worth doing it. It's worth doing.
Yeah.
2794 and 2960.
Yeah.
So what did we find? Actually, we found that Bangalore, Secunderabad, New Delhi, Kanpur
is a slightly shorter route.
shorter route than going via Kolkata.
Yeah. But of course, one thing which we had observed the other day, which is that if you look at the Secunderabad Bangalore train, it runs only 1 day a week. So that's an issue.
Right.
So that train is.
If you are happy, if you are lucky, you're going on that day.
Yeah, if you're going on that day, this is a better route.
Otherwise, go via Vijayawada.
Vijayawada, I think, is more than once a week, so you can go more often via Vijayawada. But yeah, so this is interesting.
You know, with this business of stringing together like this, and then adding the distances with this table, with matrix, adjacency matrix, you call it, right? There is some matrix operation which does this. I mean, something which.
Yeah, I think you can actually do that, right? So basically, if you look at matrix multiplication, right? So what that does is it takes these pairs in this row and that column and adds them up, right? So this is what you want to do, right? You want to take the entry from here to there, and then from there to there.
So it's like multiplying, huh?
Yeah. So you
can
get it through some kind of
matrix
multiplication. Yeah.
Okay. So there's some very interesting mathematical stuff going on here, right?
So even this thing that we said earlier about this, is there without calculating?
Without calculating.
Like if you just want to know, is there a one short route? Is there a one change 2 hop route, 3 hop route? That also you can get by this
multiplication method.
Yeah. So you can
multiply the matrices, and if the entry is non-zero, it means the entry is 3. It means that.
Yeah, so after you multiply 3 times, if you get a tick, then you have done it in 3 hops. After 4 times, you will get it in 4 hops, and so on. So you can actually do this thing abstractly using the matrix without having to do this tedious searching and doing that.
Okay.
And get it.
Of course, matrix multiplication time takes a long time.
Yeah, effectively it's doing the same thing, but it's doing it in a sense blindly. You are not analyzing it specifically.
Right.